Welcome to Lost in Disclosure. Tonight, we drift into dark water. The ocean at night is not like the ocean you know. It is not the place of sunlit beaches and rolling waves. It is not the blue horizon captured in postcards or the gentle surf that lulls children to sleep. No. The ocean at night is something else entirely. It is a void, a black mirror, a world that swallows light and sound and returns only silence. When the sun sets and the last trace of color drains from the sky, the water becomes indistinguishable from the air above it. The stars reflect on its surface, and for a moment you cannot tell where the sea ends and the cosmos begins. It is in this darkness, this profound, unsettling stillness, that something impossible has been seen. A light, not the glow of bioluminescent plankton stirred by a passing boat, not the flicker of a distant ship or the beam of a lighthouse cutting through fog. This light comes from below, from depth where no sunlight has ever reached, from places so remote, so crushing in pressure that human presence is almost unthinkable. And yet, the light is there, steady, rhythmic, structured. Sailors have reported it, submersibles have recorded it. Satellites scanning the ocean floor have detected faint signatures of illumination where none should exist. These are not random flashes. They are not the chaotic bursts of deep-sea creatures defending themselves in the dark. They are organized, precise, almost intentional. Some call them anomalies, others call them mysteries. But a growing number of researchers, investigators, and those willing to ask uncomfortable questions have begun to use a different word: beacons. Underwater beacons, placed at coordinates that repeat, emitting patterns that do not decay, glowing with a persistence that defies natural explanation. And the question that rises from the deep, slow and cold and undeniable, is this: who put them there? Or, perhaps more unsettling still, what are they signaling? The ocean covers 71% of our planet. It holds 95% of Earth's habitable space, and we have explored less than 5% of it. We map distant moons with greater detail than we map our own seabeds. We know the surface of Mars better than the trenches that lie beneath our feet. In that vast, unexplored darkness, there is room for more than fish and coral and forgotten shipwrecks. There is room for the unknown. And if the unknown has found a way to hide, to watch, to signal, the ocean would be the perfect place. Deep, dark, silent. A place where secrets could rest, undisturbed for centuries. Or longer.
But the story doesn't begin in some remote corner of the Pacific or in the cold waters of the Arctic shelf. It begins with data, with instruments, with patterns emerging from the noise. It begins with the realization that the ocean is not as silent as we thought, and that somewhere far below, something is speaking. The year was 2003. A research team operating an autonomous underwater vehicle off the coast of California was conducting a routine survey of the ocean floor. The mission was mundane, mapping geological features, collecting sediment samples, and measuring temperature gradients. Standard oceanographic work. But then the sensors picked up something unusual. A faint electromagnetic pulse, repeating at regular intervals, originating from a depth of approximately 4,000 meters. At first, the researchers assumed it was interference, equipment malfunction, background noise from tectonic activity or human-made sources, like undersea cables or military sonar. But when they replayed the data, the pattern was unmistakable. It wasn't random. It wasn't chaotic. It was structured. A pulse every 11 seconds, consistent, unwavering, like a heartbeat. They repositioned the vehicle and scanned again. The signal was still there. And as they extended their search radius, they found others. Not one source, not two, 7. 7 distinct points of electromagnetic activity, arranged in a rough hexagonal formation across the ocean floor. Each one pulsing at the same interval, each one emitting the same low-frequency signal. The team reported their findings to the National Oceanic and Atmospheric Administration. The data was reviewed, analyzed, and eventually filed under Unexplained Geophysical Phenomena. No follow-up mission was conducted, but the data remained. And over the years, other researchers began to notice similar patterns. In 2007, a sonar survey conducted near the Mid-Atlantic Ridge detected what operators described as light reflections at depths where no light should exist. The readings were dismissed as sonar artifacts, echoes caused by mineral deposits or underwater topography. But when the same survey was repeated a year later, the reflections were still there, in the exact same locations. In 2011, a deep-sea submersible exploring the Mariana Trench, the deepest point on Earth, recorded brief flashes of light near the trench floor. The video footage was grainy, distorted by pressure and darkness, but the flashes were visible, brief, bluish-white, and symmetrical. The crew could not explain them. Neither could the engineers who reviewed the footage. In 2015, an oceanographic satellite designed to measure surface temperatures began detecting faint thermal signatures in the deep ocean, localized hotspots that appeared and disappeared over periods of weeks. The signatures did not correlate with known volcanic activity. They did not match the profiles of hydrothermal vents. They were isolated, intermittent, and inexplicably consistent. And then, in 2018, a breakthrough. A joint research expedition funded by multiple governments deployed a network of advanced sonar buoys across a section of the Pacific Ocean. The goal was to study deep water currents and marine migration patterns. But what they found was something else. Beneath the currents, beneath the layers of thermocline and pressure, beneath the crushing weight of 5,000 meters of water. Lights, not reflections, not artifacts, not illusions, but lights. Captured on sonar imaging, visible in infrared scans, emitting faint but measurable radiation in frequencies just outside the range of human perception. The lights formed patterns, grids, arrays, structures that repeated across hundreds of kilometers of ocean floor, and they pulsed, not randomly, not erratically, but in sequences, in rhythms, in ways that suggested, however impossibly, purpose. The data was classified, the findings were restricted,
and the expedition's final report was marked as inconclusive. But copies of the data circulated. Researchers talked quietly among themselves, and slowly a question began to emerge from the depths of scientific discourse. What if these lights are not natural? What if they were placed? And if they were placed, by whom? The ocean, it seemed, was not just hiding mysteries, it was broadcasting them. And someone, somewhere, had been listening all along.
But the story doesn't end there. Because these lights, these signals, these beacons, they are not a recent phenomenon. They have been seen before. Long before satellites and sonar and submersibles, long before we had the technology to detect them, measure them, or even acknowledge their existence. They appear in old naval logs, in forgotten reports, in classified documents that have only recently been declassified or leaked. The earliest known reference dates back to 1952. A Soviet submarine operating in the Arctic Ocean during the height of the Cold War reported detecting underwater illumination at extreme depth. The crew described seeing a faint green glow through the periscope, not on the surface, but beneath it. Below the ice, below the layers of frigid water. The glow persisted for several minutes before fading into darkness. The incident was logged, classified, and filed away. Soviet officials assumed it was a natural phenomenon, bioluminescence perhaps, or some form of electrical discharge caused by the submarine's own systems. But the crew insisted otherwise. They described the light as stationary, structured, deliberate. One officer, years later, would describe it as a lamp left burning in an empty room. In 1964, a U.S. Navy submarine conducting deep-water reconnaissance near the Aleutian Trench detected a series of sonar contacts that defied explanation. The contacts appeared as bright returns on the sonar display, solid objects, or at least something reflecting sound waves with unusual intensity. But when the submarine moved to investigate, the contacts vanished. They reappeared hours later, in a different location, arranged in a formation that the sonar operator described as too regular to be rocks. The captain ordered the submarine to surface. The contacts disappeared, and the incident was logged as acoustic anomaly, cause unknown. In 1971, a British research vessel studying deep-sea currents near the Azores observed what the crew called phantom lights at a depth of 3,000 meters. The lights were visible on the ship's sonar imaging system, discrete points of high reflectivity that did not correspond to any known geological or biological features. The lights appeared to pulse in unison. On, off, on, off. Like a lighthouse or a signal. The research team attempted to deploy a submersible to investigate, but equipment failure forced them to abort.
When they returned to the site weeks later, the lights were gone. No trace, no explanation, just empty water. These early encounters were scattered, isolated, dismissed as equipment malfunction, natural phenomena, or the inevitable quirks of exploring an environment as hostile and poorly understood as the deep ocean. But when taken together, they form a pattern that suggests these lights, these signals, these beacons have been present for decades, perhaps longer, and that they have been waiting for what we do not know. But the fact that they have been seen repeatedly across different oceans, by different crews, using different technologies, that is harder to dismiss. Because it suggests something that challenges our understanding of the natural world. It suggests design. And design implies intention. And intention implies intelligence. The ocean, we are told, is governed by physics and chemistry and biology, by the slow grinding processes of geology and the chaotic dance of life adapting to extreme conditions. But what if there is something else down there? Something that does not fit into the categories we have built. Something that watches, waits, signals. The earliest reports are only whispers, fragments of a story that no one wanted to tell. But the whispers are growing louder. And the ocean, as always, keeps its secrets close. Years later, another case would echo the same pattern. This time, the discovery was not accidental. It was the result of deliberate investigation. In 2016, a team of marine geologists was analyzing high-resolution sonar maps of the ocean floor near the East Pacific Rise, a tectonic boundary where new oceanic crust is constantly being formed. The maps were part of a larger effort to study underwater volcanic activity and mineral deposits. But as the researchers examined the data, they noticed something that did not belong. Beneath the jagged ridges and volcanic formations, there were structures. Not natural structures, not the chaotic, irregular shapes produced by lava flows or sediment accumulation. These were geometric, circular formations, radial symmetries, patterns that repeated across kilometers of seabed with an eerie precision. And at the center of each formation, there was a point of high reflectivity, a bright return on the sonar scan that suggested something solid, something metallic, or at the very least, something far denser than the surrounding rock. The researchers ran the scans again, same result. They cross-referenced the data with geological surveys. No known natural process could produce formations like these. They consulted with engineers, physicists, and oceanographers. No one had an explanation. And then one of the team members noticed something else. The formations were not random, they were aligned. Not with magnetic north, not with tectonic plates, but with each other. If you connected the centers of these formations on a map, they formed a grid, a network, an array that stretched across thousands of kilometers of ocean floor. It was, by all appearances, deliberate. The team published their findings in a peer-reviewed journal, carefully avoiding any speculative language. They described the formations as anomalous geophysical features and called for further investigation. But privately among themselves, they used different words: architecture, design, placement, and the question that no one wanted to ask aloud: who built this? Because if these formations were natural, they defied everything we knew about geology. And if they were not natural, then something or someone had placed them there. Something with the capability to operate at depths where human technology could barely survive. Something with the knowledge to construct formations that spanned continental distances. Something that had remained hidden, undiscovered for who knows how long. The implications were staggering and terrifying. Because if there was intelligence at work beneath the ocean, then humanity's assumptions about its place in the world, its dominance, its solitude, were wrong. We were not alone. We had never been alone. We just hadn't been looking in the right place. But the story doesn't end with geometry and sonar maps, because the beacons, if that is what they are not just visual. They are not just patterns etched into the seafloor. They are active. They emit signals. And those signals, when analyzed, reveal something even more unsettling. They are not random noise. They are structured, coded, intentional, as if the ocean itself were speaking and waiting for someone to listen.
Across the world, the mystery deepened, because it wasn't just sonar. It wasn't just light. There were sounds. In 1997, a network of underwater listening devices operated by the National Oceanic and Atmospheric Administration recorded a sound unlike anything previously documented. It was loud enough to be detected across multiple sensors, separated by thousands of kilometers. It was low frequency, rising in pitch over the course of about 1 minute before fading into silence. They called it the bloop. At first, researchers believed it might be biological, the call of some massive, unknown marine creature, but analysis of the frequency and amplitude suggested something far larger than any known animal, larger, in fact, than a blue whale. Eventually, scientists concluded it was likely caused by an ice quake, the sound of glacial ice fracturing and collapsing into the ocean. The explanation was reasonable, logical, but it left unanswered questions, because the bloop was not the only unexplained sound recorded in the deep ocean. It was simply the most famous. There have been others. Low-frequency pulses, rhythmic clicks, strange harmonics that seem to emerge from specific coordinates on the ocean floor. And some of these sounds, when analyzed, display characteristics that are difficult to explain. They repeat, not every day, but at intervals, days, weeks, months. They originate from the same locations where the lights have been detected, and they carry patterns, frequencies modulated in ways that resemble, however faintly, information transmission. In 2012, a team of acoustic researchers studying whale migration patterns detected a series of pulses emanating from the abyssal plain near the mid-Atlantic ridge. The pulses occurred at regular intervals every 73 seconds and lasted for approximately 4 days before stopping. The frequencies were too low to be whale calls, too structured to be geological noise, and too consistent to be random. When the researchers attempted to triangulate the source, they found it originated from a depth of nearly 6,000 meters. far deeper than any known marine mammal could dive. They submitted their findings to a marine biology journal. The paper was rejected. The reviewers suggested the data was likely corrupted or misinterpreted, but the researchers kept the recordings. And when they played them back, slowed down and filtered to remove ambient noise, something emerged. Not words, not language as we understand it, but structure. Patterns within patterns, repetitions, sequences that seemed to build on one another as if constructing meaning. It was, one researcher said, like listening to a conversation in a language you don't understand. You know it's language. You can hear the rhythm, the syntax, the intention, but the meaning remains just out of reach. And that was the most unsettling part. Because if these sounds were natural, volcanic vents, tectonic shifts, underwater landslides, they should be chaotic, random, unpredictable. But they weren't. They were organized. And organization implies order.
And order implies design. And design implies something we are not ready to name. The ocean, it seemed, was not just glowing in the dark. It was speaking. And the question that haunted researchers, that kept them awake in the quiet hours before dawn, was this: if it's speaking, who is it speaking to? Not us. We didn't discover these signals intentionally. We stumbled upon them, found them by accident while looking for something else. So if the signals are not meant for us, then perhaps they are meant for something else. Something in the ocean, or something that once was, or something that will be. The thought is almost too large to hold, because it suggests that the ocean is not just a body of water, not just a habitat for fish and whales and coral. It is a repository, a vault, a place where messages have been left, encoded, preserved, waiting. Waiting for the right listener or the right time. And if that is true, then humanity's exploration of the ocean is not just a scientific endeavor. It is a search for something far older, far stranger than we ever imagined. We are not discovering new species or mapping unknown terrain. We are uncovering evidence. Evidence that something was here before us, or is still here, watching, listening, waiting. And the beacons beneath the waves are not anomalies. They are markers, signposts, pointing toward a truth we are only beginning to glimpse. And yet, even that explanation leaves a shadow of doubt, because not everyone is convinced. For every researcher who believes the beacons are evidence of intelligence, there are others who insist the truth is far simpler. The ocean, they say, is strange by nature. It is a place of extremes, a phenomena that defy easy explanation, not because they are impossible, but because they are rare, underexplored, poorly understood. Dr. Marcus Holt, a marine geologist with decades of experience studying underwater volcanic systems, is one such skeptic. We see patterns everywhere, he says. It's how our brains are wired. We look at clouds and see faces. We look at rock formations and see pyramids. The same thing happens when we encounter unusual data from the deep ocean.
We see structure where there is only chaos. Holt argues that the so-called beacons can be explained by a combination of natural processes. Bioluminescence, for one. Deep-sea organisms, jellyfish, squid, bacteria, produce light through chemical reactions. In large numbers, they can create glowing formations that appear structured or coordinated. Imagine a massive bloom of bioluminescent plankton drifting along an underwater current. From above, it might look like a grid, a pattern. But it's just biology following the physics of water movement. He also points to volcanic activity. The ocean floor is not static. It is constantly shifting, cracking, releasing gases and minerals. In some cases, these releases can produce light, a phenomenon known as triboluminescence, where crystals emit photons when fractured.
Underwater landslides, methane releases, tectonic stress. All of these can generate brief flashes of light, Holt says. They're rare, yes, but not impossible. As for the electromagnetic pulses and acoustic signals, Holt suggests they may be caused by underwater electrical discharges, natural batteries formed when seawater interacts with certain minerals. The ocean is full of chemistry, he says, and chemistry, under the right conditions, can produce electrical currents. Those currents can interfere with instruments, create magnetic anomalies, even generate sound. It is a compelling argument, grounded in science, supported by evidence. But it doesn't account for everything. It doesn't explain the geometric formations detected on sonar, the perfect symmetry, the repeating intervals. It doesn't explain why the signals appear at the same coordinates year after year in oceans separated by thousands of kilometers. It doesn't explain the structure in the acoustic data, the patterns that resemble information, not noise. And it doesn't explain why so many of these phenomena cluster around areas of the ocean that are otherwise unremarkable. No volcanic vents, no unusual geology. Just deep, flat, empty seabed. Dr. Amelia Cross, a physicist who has studied the electromagnetic signatures detected near the Puerto Rico Trench, remains unconvinced by the skeptical explanations. Yes, natural processes can produce light, sound, and electrical signals, but not in the way we're seeing here. The consistency, the precision, the repetition, those are hallmarks of artificial systems, not natural ones. She points to a specific case, a series of electromagnetic pulses detected near the Puerto Rico Trench in 2014. The pulses occurred every 11 seconds, without variation, for a period of 6 days. That level of regularity is almost impossible in nature. Even the most stable geological processes, tidal cycles, tectonic rhythms, show some variation. But these pulses? Perfectly consistent, down to the millisecond. She pauses. That's not geology. That's engineering. The debate continues. Skeptics insist the beacons are natural. Believers argue they are artificial. And caught in the middle are the researchers who simply don't know, who look at the data and see both possibilities, who understand that the ocean is capable of producing wonders we have never imagined, but who also understand that the ocean is vast enough, deep enough, to hide wonders that were never natural at all. And so the question remains unanswered, not because we lack data, but because the data points in two directions at once, toward the known and toward the unknown. And the line between them, it seems, is thinner than we thought. If you were an advanced civilization exploring the galaxy, she says, and you wanted to leave evidence of your presence, you wouldn't rely on monuments or inscriptions. Those decay, they erode, they get buried or destroyed. No, she continues, you would leave something functional, something that could persist for thousands, maybe millions of years, something that could broadcast, signal, announce itself when the local inhabitants reached a certain level of technological development. She gestures to the data, the sonar maps, the acoustic recordings, the electromagnetic signatures. These beacons, she says quietly, might not be calling out to space. They might be calling out to us, telling us they're here, telling us to dig deeper. It is a radical idea, one that challenges every assumption we have about history, evolution, and our place in the cosmos. But it is not without precedent, because throughout human history, there have been accounts of strange lights in the ocean, of objects descending into the water, of encounters with something beneath the waves that defied explanation. Ancient mariners spoke of glowing cities beneath the sea, of lights that rose from the deep and vanished into the sky. Modern witnesses described similar phenomena, UAPs, unidentified aerial phenomena, entering and exiting the ocean with no apparent disturbance. In 2019, the U.S. Navy released footage of such an event, a spherical object tracked by military aircraft descending into the ocean off the coast of California. The object did not slow, did not impact the surface with any visible splash. It simply entered, as if the water were not there. And when sonar attempted to track it underwater, it vanished, gone, without a trace. These incidents are rare, but they are documented, recorded, witnessed by trained observers using advanced equipment, and they suggest something that is difficult to accept. That the ocean is not just a habitat for marine life, it is a gateway, a threshold between worlds. And the beacons may not be ancient relics at all. They may be active, current, part of a network that is still in use, still transmitting, still waiting for a response. Dr. Vargas does not claim to have answers, but she believes the questions are worth asking. We spend billions searching for life on Mars, on Europa, on distant exoplanets, she says. And maybe we'll find it there. But what if we're missing something closer? What if the evidence we're looking for is not in the stars, but in the water? She looks at the maps, the data, the patterns. We've explored 5% of the ocean, she says. What do you think we'll find in the other 95? It is a question without an easy answer. But it is also a question we can no longer afford to ignore. Signals without a sender. That is how one researcher described the beacons. Because even if we accept that the lights, the sounds, the electromagnetic pulses are real, even if we accept that they are artificial, placed, deliberate, we still do not know who or what created them. And we do not know why.
The beacons do not communicate in any language we recognize. They do not transmit images, symbols, or messages in a form we can decode. They simply pulse, repeat, wait. In 2020, a collaborative research project involving oceanographers, physicists, and computer scientists attempted to analyze the acoustic signals detected near one of the beacon sites. They used machine learning algorithms to search for patterns, structures, anything that might indicate intentional encoding. What they found was inconclusive. The signals were not random, that much was clear. They contained repeating motifs, variations that seemed deliberate, and intervals that suggested timing, as if the signals were counting. But whether they were counting time, or distance, or something else entirely, no one could say. One researcher, Dr. Samuel Okoye, described the process as trying to translate a language when you don't know what a language is. He said, "We recognize structure, but we don't recognize meaning. It's like hearing music from a culture you've never encountered. You know it's intentional. You know it's not random noise, but you can't understand what it's trying to express." The signals, he suggested, might not be meant for human interpretation at all. He said maybe they're automated, beacons left by a probe or a vehicle that passed through our solar system long ago, set to transmit on a loop, forever, until they decay or someone finds them. Or, he added, they might be active communication, but not directed at us. What if the beacons are talking to each other, a network? Nodes passing information back and forth. We're just intercepting the transmissions. It was a humbling thought that the ocean might be filled with signals, conversations, data streams, and we are simply bystanders, eavesdroppers on a dialogue we were never meant to hear. But there is another possibility, one that is rarely spoken aloud, but lingers in the background of every discussion about the beacons. What if the signals are a test? A way of determining whether a species has reached a certain level of technological sophistication.
Because the beacons are not easy to find. They are not obvious. They require advanced sonar, deep sea exploration, electromagnetic detection equipment, technologies that only became available in the last few decades. Before that, the beacons would have been invisible, inaccessible, hidden. But now, we can detect them, analyze them, study them. And perhaps that is the point. Perhaps the beacons are not meant to communicate information. Perhaps they are meant to be discovered, to serve as a milestone, a marker, a way of saying, you have reached this level. Now, what will you do next? It is a provocative idea, one that suggests the beacons are not passive relics, but active challenges, that they are waiting for us to prove ourselves, to demonstrate curiosity, persistence, intelligence. And if we do, what happens then? Do the beacons respond? Do they activate? Do they reveal something more? Or do they simply continue to pulse, indifferent, uncaring, as they have for centuries or millennia? We do not know, because so far, no one has been able to interact with the beacons, to touch them, to alter them. We can only observe, listen, wonder, and hope that one day the signals will make sense, that the ocean will give up its secrets, or that whoever placed the beacons will return, and finally, after all this time, answer the question we have been asking since the first light was seen beneath the waves. Why are you here?
Between stars and seas, there is a symmetry to it, isn't there? The ocean and the cosmos, two vast, dark, largely unexplored realms, two places where humanity stands at the edge, peering into the unknown, hoping for a glimpse of something beyond ourselves. We have always looked to the stars for meaning, for answers, for signs that we are not alone. Ancient astronomers mapped the heavens, searching for patterns in the movements of planets and stars. They built monuments aligned with the solstices, the equinoxes, the rising of constellations. Modern scientists build radio telescopes, space probes, deep space observatories. They scan distant galaxies for signals, for technosignatures, for the faint whisper of another civilization calling out across the void. We want to believe, we want to find, but perhaps all this time we have been looking in the wrong direction, because while we stared upward, something was waiting below. The ocean is Earth's last frontier, the final unexplored territory on a planet we claim to know. And yet it is more alien to us than the surface of Mars. We cannot survive there without technology, without pressure suits, submersibles, breathing apparatus. We cannot see in its darkness, cannot withstand its cold, cannot endure its depths. It is, in every meaningful sense, a hostile environment. And yet it is teeming with life, with ecosystems so strange, so unlike anything on land, that encountering them feels like stepping onto another world. Creatures with no eyes, no bones, no recognizable organs. Life forms that thrive in boiling water or freezing brine, that generate their own light, that feed on chemicals instead of sunlight. The ocean teaches us that life is adaptable, resilient, capable of evolving in ways we never imagined. And if life can take such strange forms here on Earth, what might it look like elsewhere? On Europa, with its subsurface ocean locked beneath miles of ice? On Enceladus, where geysers of water vapor erupt from cracks in the frozen crust? On distant exoplanets, covered entirely in water, with no land, no continents, nothing but ocean from pole to pole. If we want to understand alien life, perhaps we should start by understanding the alien life that already exists in our oceans. And if we want to find evidence of extraterrestrial visitors, perhaps we should stop scanning the skies and start exploring the seabed. Because the beacons, the signals, the lights, they are not in space.
They are here, right beneath us, in the one place we have spent centuries ignoring. Dr. Yuki Tanaka, an astrobiologist and oceanographer, has spent her career studying the parallels between deep-sea exploration and space exploration. The deep ocean and outer space have more in common than most people realize, she says. Both are extreme environments. Both require specialized technology. Both are vast, dangerous, and largely unknown. But there's one key difference, she continues. Space is empty, mostly. The distances are so vast that even if life exists out there, the chances of encountering it are slim. The ocean, on the other hand, is full, packed with life, with chemistry, with energy. It's not empty space, it's dense with possibility. She believes that if extraterrestrial intelligence has visited Earth, or is still here, the ocean is where we should look. It offers cover, concealment, a place to hide, observe, operate without being detected. If I were an advanced civilization studying a planet like Earth, I wouldn't land on the surface. I'd set up a base underwater, where no one would see, where I could watch, listen, and learn.
It is a logical strategy, and it raises an uncomfortable question. What if they're still here? Not ancient visitors who came and went millennia ago, but current observers, watching, waiting, recording, using the ocean as a veil. The thought is unsettling, but it is also strangely comforting, because it means we are not alone, have never been alone. It means the universe is not empty, cold, indifferent. It means somewhere, in the darkness, there is something else, something watching, something aware. And perhaps one day we will be ready to meet them, not as conquerors or explorers, but as neighbors, as fellow travelers in the vast, mysterious cosmos. Until then, we have the beacons, pulsing, glowing, waiting, reminding us that the universe is stranger than we know, and that the greatest mysteries are not always far away. Sometimes they are right beneath our feet. The silent frequencies. That is what they are called now. The signals that drift through the deep, too faint for most equipment to detect, too subtle for the human ear to hear. But they are there. Modern expeditions have tried to locate the beacons, to pinpoint their exact coordinates, to send submersibles down to investigate. Some have come close enough to detect the signals growing stronger, close enough to see faint glows on sonar imaging. But when they arrive, when the submersibles descend to the coordinates, when the cameras sweep across the seabed, there is nothing. Just rock, sediment, empty water. The signals vanish, the lights fade, and the ocean returns to silence. It is as if the beacons know when they are being approached, as if they are aware and choose to hide. Dr. Isaac Maboru, a deep-sea robotics engineer, has led 3 expeditions to beacon sites. Each time, the results were the same. We'd get strong readings from above, he says, clear signals, clear electromagnetic signatures. But the moment we sent the ROV down, everything stopped. He describes it as frustrating and maddening. It's like trying to catch smoke. You know it's there, you can see it, but when you reach out, it's gone. Some researchers believe the beacons are mobile, capable of moving across the seabed, relocating when they detect approaching technology. Others think they are cloaked, using some form of advanced camouflage or electromagnetic shielding that renders them invisible to conventional sensors. And some believe they are simply deeper than we can reach, that the signals we detect are echoes, reflections, projections from sources buried far beneath the ocean floor in places we cannot access. Whatever the truth, the result is the same. The beacons remain elusive, just out of reach, visible only from a distance. And the deeper we look, the more we realize how little we understand. Dr. Maboru recalls one expedition in particular. They were investigating a beacon site near the Mariana Trench. The signals were strong, consistent, and they had brought new equipment, advanced sonar arrays, high-resolution cameras, electromagnetic scanners, everything they needed to finally capture definitive evidence.
The ROV descended slowly, transmitting data as it went. At 3,000 meters, the signal was still strong. At 4,000 meters, it was growing louder. At 5,000 meters, the ROV's cameras detected a faint glow in the distance. We saw it, Mburu says, just for a moment, a pale blue light maybe 100 meters ahead. The ROV moved forward, the light remained steady, and then, without warning, the ROV's systems failed. Cameras went dark, thrusters stopped, telemetry ceased. The ROV drifted, dead in the water for several minutes before systems suddenly rebooted. When the cameras came back online, the light was gone, and the ROV's data logs for the previous 10 minutes had been erased. It wasn't a malfunction, Mburu says. The systems shut down, deliberately, as if something had switched them off. He doesn't claim to know what happened, but he is certain of one thing. Whatever is down there, he says, it doesn't want to be found. Not yet, anyway. And so the expeditions continue. The searches go on. Researchers return to the sites year after year, hoping for a breakthrough. But the ocean remains silent. The beacons remain hidden, and the mystery endures. Perhaps it is meant to. Perhaps the beacons are not meant to be found, not in the conventional sense. Perhaps they are meant to be sought, to inspire curiosity, to drive exploration, to remind us that the universe is vast and strange and full of wonders we cannot yet comprehend. And perhaps one day, when we have learned enough, when we have grown enough, when we are ready,
The beacons will reveal themselves, the signals will become clear, and the ocean will finally speak. Until then, we listen, we search, we wonder, and we drift through the darkness, guided only by the faint glow of lights we cannot reach. The beacons beneath the waves, silent, patient, eternal, waiting.
Thank you for drifting with us tonight into the cold and quiet places where questions outnumber answers. The ocean holds many secrets. Some we have uncovered, others remain hidden, waiting in the depths, glowing faintly in the dark. The beacons, if they exist, are not just mysteries. They are invitations. Invitations to look deeper, to ask harder questions, to accept that the world is stranger than we have been taught to believe. And whether they are natural or artificial, ancient or active, relics or signals, they remind us of something important, that we do not know everything, that the universe is vast, that mysteries remain, and that sometimes the most profound discoveries are not found by looking up at the stars, but by looking down into the depths we have spent so long ignoring. If tonight's story stirred something in you, curiosity, wonder, perhaps even a little unease, then it has done what it was meant to do. Share your thoughts below. What do you believe the beacons are? Have you heard similar stories? Do you think we are alone, or has something been watching all along? And if you'd like to continue drifting with us through the unknown, subscribe. More stories await, more mysteries, more questions that resist easy answers. Until next time, keep searching, keep wondering, and remember, the ocean is deep, and the lights beneath it are still glowing. Good night.